Hey everybody, this is Larry. This is June 9th of the year 2025. I don't really do that many of these anymore for whatever reason, just been busy training and all these things. But today we are going to do a random problem. So, I mean, you probably know what the random problem is because it's in the title. But for me, I don't know yet as I'm doing this. It signed me out. Give me a second. Let me log back in. But the idea, so what I'm going to do is that I'm just basically trying to, why is, maybe something crashed. I am trying to do a random problem that I haven't done before. That's basically the idea. Since, there are a lot of those, and make a video from it, right? I've apparently 2,900 solved now, but yeah, let's do a filter. We do, I don't know, I feel like it's hard these days. Anyway, yeah, and we'll keep it algo for now, and then let's hit on this random RNG button. Let's go. 5, 4, 3, 2, 1, go. And today we have 1104 path in zigzag labeled binary tree, medium problem. In an infinite binary tree where every node has 2 children, the nodes are labeled in row order. Okay, what does that mean? In the odd number rows, go left to right, and the even number rows, right to left. Okay, fine. Given the label of a node in this tree, return the labels in the path from the root of the tree to the node with that label. Okay. I mean, I think this is not that too bad. I mean, I think the first thing you should know about this kind of thing, let's say without the weird reversal of going left to right, is that it's going to be 1, and then it's going to be 2, 3, 4, 5, 6, 7, right? Something like that. And the idea here is that for every node x, you have on the left side, you have 2 times x, and on the right side, 2 times x plus 1, right? And you can hold for every number, right? 2 to 5, 3, 6, 3, 7, right? So this is the case for every number. And then the idea here is just that, well, if you know, so now you're just trying to find, given a label, and of course in this case, all the nodes on the left side are even, and all the nodes on the right side are odd, right? Okay. And then now it's just up to you to kind of flip the labels on every other row after that. I think that's it, right? Because everything is consistent. So if you know this is 2, for example, if you know one of the rows, let's say here we have, what is that? Yeah, the last row on this label, which is 15, 14, 13, 12, 11, 10, 9, 8. And we could just ignore it and treat it as 8, 9, 10, 11, 12, 13, 14, 15, right? Whoops. And then now we just go, okay, well, let's say the number is 17. So 17, the parent's 8, right? That's fine. And then you have 8, 4, 2, 1, right? But you know that for 17, we have 8, 4, 2, 1, maybe? Yeah. And in that case, we know that for all the even ones, we have to flip. So the 2, we just flip. So then basically you do some math and you get 3. 8, you do some math, it's going to be 15, and that's it. Yeah, I mean, that's basically the idea, the strategy, nothing too crazy, I think, after you recognize those points. So let's go, right? So then now we have path is equal to do, right? So while label is greater than 1, I guess, no, just greater than 0, I suppose. Yeah, and then path append label, level by 2, right? And that's it, right? So then now we can print path. We could even return it. I mean, returning is fine. We're not going to get the right answer, right? But this is a placeholder. But yeah, you can see that we have, this thing. And of course, we have to reverse. Actually, did know that because we're going up instead of down, right? And then now we know, as we said, for every even node, oh, yeah. I see. This is actually a little bit annoying. Well, actually, it's interesting because I actually was wrong in my initial idea, or maybe just imprecise. I thought that here you can just go up the path and then label it, right? But one thing I did not consider is that 14 itself may be reversed, right? For example, you look at here, 14 is reversed. So then, what does that mean? That means that actually you reverse every node, every other node up instead of just the. So actually, you reverse the nodes that are of different heights from the original leaf node and not the parent node, which is actually interesting. I actually did not expect that, and that's why you print things out and play around with it. But that, and one, of course, it just goes to one, so that's why. But yeah, and then now yeah, so then the math is annoying, but it's not that bad because it's just every row is 2 to the I, right? So then now we go yeah, for I in range of length path, right? So then do we reverse? We reverse if I mod 2 is equal to length of path mod 2, I think, right? Meaning that yeah, so oh no, if it's not equal to, yeah, right? Oh wait, no, path is not the same. It's basically we have 14, we want to do all the other ones, right? But length of path is not quite the same because the index of the last node is yeah, so you kind of inverse it and this is it, right? Because the index of the last node is not going to be the same as that. That's why. Did I get this right? Yeah, I mean this is right. And then now you reverse this, right? Reverse the numbering, right? And I, for the first row, is going to be 2 to the 0, which is 1. The second was 2 to the 1, which is 2. That's not right, right? I think this is what happens when you have one base stuff. It's kind of confusing. But okay, so yeah, yeah, it's just 2 to the I. It's not an XOR. Plus 1, right? Because it's just one base. So then now that's the last cell. So, and then the first cell is it's not 2 to the I. It is 2 to the I minus 1, I think. Right? Or just this divided by 2. I think that's fine, right? So basically, last is equal to power of yeah, let's do power of 2 to the I plus 1, and then yeah, and then you just flip that. How do you flip it? So yeah, so first is equal to last divided by 2, I think. Plus 1 maybe, because 3 you get 2, 4 or 7 you get 4, so actually it's just plus 1 divided by 2, right? And then yeah, path sub I, so delta is equal to last minus this, and then now path sub I is equal to we just added to delta, I think. No, it's equal to first plus delta. I'm sure there's a cleaner formula, but I think that's roughly right. It could be off by 1, but whoops. I mean, clearly this is very wrong. Alright, well. One, two. I mean, this is clearly wrong then, right? Because last of I. Let's put no I. First, I mean, because it should be either 2, 3 or something like that. So I'm just really wrong on this math. Yikes. Right? So 0, I is 0. So we want to swap. Okay. Should be 1, 1 actually. So first is right. Maybe, but it's based on last, so it's not right. So 2 to the 0 is 1. So okay, so is that right? looks okay. So 1 1 2 4 is wrong. So that's still not right. 2 is so last number is 4. That's right. And then this is yeah, right. I think that's right. Okay, so then now 3 4. So we're just trying. Oh no, 3 4 is wrong. What is? Is this one? So this one actually should be 4 7. So this is just wrong. So 0 1 2. So to get 8, it should be this. Am I just wrong? Did I have to press 1 in the wrong place? 0 1 2. 2 should be 4 7. Right, and then 1 1. So yeah, I don't know what I had before, but yeah, I don't know. This looks really wonky, and I'm trying error, but it's just trying to get the last number to be the last number in this thing. But it should be easier than this. I don't know why I'm so bad at this. I think, well, the reason is because I'm used to doing this with 0 index, so now having 1 index is a little bit awkward because 0 index is just 0 1 2 1 3 4 5 3 1 2 0 1 2 3 4 5 6. Is that right? Huh, wait, what? Am I just confusing myself? So you have 0. Next one is going to be 1 2 3 4 5 6. That's 4 elements. Maybe this is hard too. I don't know. 7 8 9 10 11 12. I don't know. I guess this number is a little bit awkward. I mean, it's plus 8 or whatever, so it's I don't know why. But anyways, this looks okay now though, so let's I don't know, sometimes you just have to work out the math. And let's give a quick submit, and we are good. And that's it. Gonna keep it straightforward, simple for now. What's the complexity here, right? This is going to be linear time in the size of the input, right? The size of the input is the number of bits. You could say that maybe it's bit square to hold this, but I don't know. Maybe that's fair, actually. I don't know. Either way, it is pretty fast. This loops the number of bits, right? Okay, maybe this is n squared if you want to think of it that way. Because if n is the number of bits, and there will be n squared space because, for example, if label is 10 bits, 2 to the 10, then now it increases a 10 number, then plus 9, plus 8, plus 7, and then that's going to be n squared in the number of bits. So this is technically n squared. Reverse is just n though, I think. Yeah. And yeah. I don't know, math gets a little bit wonky when you want to think about a number of bits and operations, because technically, these are still very cheap, but even this one is like a I loop, right? In theory, I guess not. It's not a loop because it's a pow, so it is actually log I. But yeah, anyway, alright, it's fast. Is what I'm going to say. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.